Hello. In this example, we will see a crashing example from project management. In the right-hand side, there is a table given with activity A to H, and the normal time and the crash times are being given to you. When you see normal time, that's how long it will take to run a certain activity. Crash time is actually crash 2. So the minimum time we can do and run activity A is 14 weeks. So it means that if we want to crash activity A, we can crash it only by 2 days. So I created a new column here on the right, calculating weeks possible to crash, and you can see the calculation. Also, it's been given the normal crash cost and the normal cost, and the crash cost. The same thing, $2,000 will cost you to run the activity in the original time, and 4,400 will cost you to run it in the crash time. So in order to know how much it costs to crash 1 week, you need to do the calculation of the difference between the cost divided by the weeks possible to crash. So if you do that calculation, you get 1,200 for activity A. And I did that for the rest of the activities. Let's assume that this network diagram that we just solved with the normal time in the duration is the earliest that we can finish this project is 36 weeks. And let's assume management target is to try and shrink the time for completion to 30 weeks. So far we can see that our critical path is ADH. And the question that we'll ask ourselves is what next? So we look usually at the activities, and we look at the week possible to crash, and we look at the cheaper cost per activity on the critical path. So we need to compare between A, D, and H. A have a highest crash cost per week. D have 700 and H have 600. So actually H have the lowest crash cost per week. Now, we need to reduce from 36 to 30, and it's very tempting to go and crush 5 weeks from H and that's it. But the problem is that we allow 2 crashing bulks until a new critical path has been formed. And if you'll try and crash 1 unit, you'll see the critical path ADHs remain the same. But if you crash 2 units, you'll see that ADH is not the only critical path after crashing 2 units. So that's why we will stop this step number 1. We will crash activity H by 2 weeks. It costs us $600 per week, so overall $1,200. So the next step is we'll go and see how the network looks like when we're actually reducing the 15 weeks of normal time for H to be 13. So I'll click here to move to step number 2. And here I am in step number 2. I'll zoom in a bit. And in step number 2, you see I reduced the crash time for H to 13. I reduced it by 2 weeks. And what happened, you can see now we have 2 critical paths, ACG and ADH. So the next step is, and that's why I didn't crash it by 5 weeks in the beginning and only by 2 weeks. So now we can see H have only 3 weeks left possible to crash. Next step is, because we have 2 critical paths, we need to crash 1 unit from each critical path, 1 activity that have the lower cost per week. Now we're going unit by unit. So which unit on ACG has the lowest crash cost per week? So A is 1,200, C is 700, and G is 500. And on ADH, we have A is 1,200, D is 700, and H is 600. And I think I said before C is 700, but no, C is actually 100. So if you look carefully, the cheapest on ACG will be activity C, and the cheapest on ADH will be activity H. Now, what we can also see that activity A is a common activity for both paths. So before we go and crush 1 unit per critical path, we check to see if we can crush one activity that might be cheaper, but actually we see that crashing the two activities H and C by 1 unit is a total cost of 700 compared to crushing A, which is 1200, so it's still not worth it. So our next step is to crush 1 week from H, 1 week from C. Let's click and see how this will be done. So here it is, here's the network, and you can see we crushed 1 week from C and another week from H. And if you look at the table now, H reduced the possible weeks to crush 2 and C reduced to 1. And we can see no change on the 2 critical paths, so we need to continue to the next step and still crash more. We're in 33, we need to reach 30. So what we, again, do the same test. Which activity should we crush on each critical path that have the lowest crash cost per week? We crush unit by unit. And comparing it to A, to 1200, to see if it was to go with A only. But we still see that it's better to go and crush H and C. So we're crushing each one of them by 1 unit. Let's click to see the next step. And here is the next step. We're crushing again C by 1 unit and H by 1 unit. If you look at our schedule now, we will not be able to crush C anymore if we'll need it. In H, we have only 1 week left. As a result, nothing have changed in the critical path. So now we continue to the next step. We reached 32 weeks, so we still need to crush 2 more weeks. So again, crushing 1 unit on each critical path, that will impact only by 1 week to the end. So which one are cheapest? So we can't crush C anymore on the ACG. So the only option is to take G, which is the second cheapest, which is $500 per week. We'll crush it by 1 week, and we will crush H, which is the cheapest for the second critical path. Let's click here and see the result of the network. Here it is. We crushed G and we crushed sorry, H. And you can see now that if we'll not be able to crush H anymore, we'll not be able to crush C anymore. With G, we still have space. When we crush these two, still you can see that the two critical paths are not changing. So what is the next option? So either to continue with finding 2 activities on each critical path and crush it by 1 week, for example, G and D, which are the possible 2. That will give us 1200 cost, or because A is 1200 cost per week, we can crush only A and reduce the project to 30 weeks. So either way will give us the same results. So first of all, let's click and see option number 1, crushing G and D 1 unit each. So here it is. We can see we actually got now 3 critical paths in the network, but we reach our destination at 30 weeks. So we stop here, and we can see that the total cost of crushing, the minimum total cost is $4,900. If we were going with only crushing A by 1 unit, critical paths are not changing. We're still working with 2 critical paths. We achieved the target of 30 weeks overall, and you can see that the total cost, again, minimum total cost is $4,900. So both options achieve the same lower cost in the crushing process. I hope you had a clear understanding of the crushing methodology. Thank you.